Do I need to convert the cos thetas and sine thetas into something?
Yep. So into the form r cos theta minus alpha. Let me get this. Oh, I should be able to remember it. So cos theta minus alpha. Do you remember what that's the same as?
Cos A minus B.
Yep. What is cos A minus B?
Is that like cos theta, cos alpha plus sine theta, sine alpha?
Yep. Theta sine alpha. What we have here is 2 cos theta. I'll write that as cos theta times 2. And 5 sine theta. Sine theta times 5.
Okay.
And so by inspection, match them up.
So do I need to do? Will that just be what is that? 2 cos theta cos alpha plus sine theta, 5 sine theta, or
Just by inspection, what do you know about cos alpha and 2?
are they the same?
Yeah. And so construct equations.
Sorry, how do we know that?
So cos theta minus alpha is the same as this, yeah?
Yeah.
We want to write this thing. So I just wrote this as cos theta times 2 instead of 2 cos theta. So we want to change this into the form cos theta minus something.
Okay.
What do you know about cos alpha and 2?
That they're the same.
Yeah. So cos alpha equals 2.
So alpha is equals to arc cos of 2.
Yep.
So should I work out what alpha is then?
Yep.
Oh yeah, you can't do arc cos of 2.
True. Anything else we know about alpha?
We know that. Oh, so sine alpha is equals to 5.
Mm-hmm.
And we won't be able to do arc sine of 5 either, will we?
No. But what can we do?
Can we do a simultaneous equation?
Yep. How can you solve them simultaneously?
Should I do like... do I need to do... times...
One,
sorry.
1 divided by 2.
So that'll be tan alpha equals to 5 over 2.
Yep.
And then just do arctan of 5 over 2.
Yep.
And the answer I got here is 68.2.
68.2 degrees. And so that is 68.2. We want R, the number in front. Do you remember how you get that?
Do I need to factorize?
Pythagoras with 2 and 5.
So I need to do square root of 2 squared plus 5 squared.
Yep.
And so will that be square root of 29?
Yep. And so 2 cos theta plus 5 sine theta is the same as what?
Root 29.
Root 29. Cos theta minus alpha. And what is alpha?
68.2.
That's it. So we have 2 cos theta plus 5 sine theta. We want to write it as cos theta minus alpha with some coefficient in front. To convert a mixture of cos of one angle, sine of one angle into cos of an angle with 2 parts, we just do the double angle formula in reverse. So cos theta minus alpha, if you expand it out, you would get this thing. And so you can see how cos alpha must be equal to 2, sine alpha must be equal to 5. And so simultaneously, alpha is 68.2. And then using Pythagoras, r is root 29. Any questions with that?
No.
Hold on, let me just make sure. Yep, 68.2. Okay, part B.
Okay. So it says hence.
Yeah.
Usually means use the answer from the previous question.
Yeah.
So would I need to do root 29 cos 0 minus 68.2 equals to 3?
Yeah, theta, not 0.
I'm sorry, theta, my bad.
Yeah. That's it. And then you solve that.
And I think here I need to do, this is where I need to do, so 3 divided by root 29.
Mm-hmm.
And that'll be equals to 3 times root 29 over 29.
Okay.
And then is this one to do like theta minus 68.2 equals to A?
Yep.
Yeah. So and so it would be like cos A equals to 3 root 29 over 29.
Yeah.
And then I need to do arc cos of that and get the answer in degrees.
Yep.
I got 56.1.
Okay.
And then because it's cos, do I need to do 360 minus 56.1?
Yeah.
And that will be 303.9.
3.9. And let me check something here. So the question tells us that theta is between 0 and 360.
Yeah.
We have theta minus 68.2. And so what is that between?
Minus 68.2 and sorry. And in between 291.8.
And so does that change anything?
Yeah, my answer can't be 303.9.
So that's outside the range. So what other answer can we get?
Oh, would I need to minus 56.1 from 303.9?
No. It repeats every 360.
Oh. So should I do I do 0 minus something?
Do your answers plus or minus 360.
So, if I do 56.1 minus 360, oh no, that'll be too much. If I do 303.9 minus 360,
yep,
and that would be equals to minus 56.1.
Yeah, makes sense because cos is symmetrical about the line x equals 0, the y-axis. And so, okay, what's next?
And now, do I need to do theta minus 68.2 equals to these answers and then solve for theta?
Yes.
Okay. And so do I need to, yeah. So for 56.1 on its own plus 68.2, I got 124.3.
Okay.
And after that, I got 12.1.
12.1, 124.3, 12.1, 124.3. So big picture is hence. So use what you did in part A. Use that form. So like if you have a mixture of sine and cos and something else, you won't be able to solve it. So you put it in the form of cos, like just one thing. So there's no sine. Put it in that form and solve it. Yep. Any questions about that?
No.
Let me see this. I might come. Yeah, hang on. They're not messing around. Yeah, this looks good. Yeah, exam question. Let's try it.
Okay. So so sine theta plus alpha, I need to find out the formula for that.
Yeah, do you know it?
Is it? No, I'm not sure.
It's given to you. Sine theta cos alpha plus cos theta sine alpha.
And so here, do we know that cos alpha is equal?
Go on.
Yeah, so is cos alpha equals to 1?
Yep.
And so is also sine alpha equals to 3?
Yep.
And so tan alpha is equals to 3?
Yep.
And so now I need to do arctan of 3.
Mm-hmm.
I got 1.6.
Degrees?
Yes.
1.6 degrees?
Oh, no, 71.6 degrees.
Oh, sorry. I thought you said 1.6 degrees. Okay, what's next?
Now, so we know that alpha is 71.6. Do I now need to sub it into like r sine theta plus 71.6?
Okay.
Oh no, now I need to do square root of 3 squared plus 1 squared to get those. And that would be square root of 10, I think.
Okay, yep.
And so would the final thing be like square root of so is it r is equal to square root of 10 and alpha is equal to 71.6?
Yep. And so what is sine theta plus 3 cos theta in the form r sine theta plus alpha?
R sine root 10 sine theta plus 71.6.
Sine theta plus 71.6. That's it. Part B.
Now that means that sine theta plus 3 cos theta equals to 2.
Yep.
And it'll be root 10, plus sine theta plus 71.6 is equals to 2.
That's also true. Yeah.
Do I now need to do 2 minus root 10?
This isn't plus root 10, it's times.
So 2 divided by root 10.
Yep.
Which will be root 10 over 5.
Okay.
And so will the final thing be like let A equals to theta plus 71.6?
Yep.
And then it'll be sine A to root 10 over 5.
Mm-hmm.
And so A is equals to uh 39.2.
Okay.
And do I need to do like if it was like 0 is smaller than theta is smaller than 360, I now need to change that, don't I?
Mm-hmm.
And that'll become 71.6 is smaller than theta plus 71.6. smaller than 431.6.
Okay.
And so does that mean that we know that A isn't an answer, like the first one, but would it be like 180 minus 339.2?
Yep.
And so that's equals to 140.8.
140.8. Okay. Go on.
And then so I need to take out the 39.2.
Yeah. How can we get an additional answer? And how did we get an additional answer for the previous one?
We did 303.9 minus 360.
Okay. What can we do this time?
Put it into our calculator and hope it gives us all the answers.
Or so it repeats every 360. This time it's between 71 and 431. We have 39. That's too small. How can we use it to get an additional answer that is in the range?
39.2 plus 360.
Yep.
And that would be 399.2.
So those two are in the range.
Yeah.
And so what is next?
Solve for theta.
Yep.
So that would become 327.6.
Okay.
And and 69.2.
69.2.
But won't 69.2 be wrong because it's not within the range?
It's not within the range of theta plus 71.6, but it is in the range of theta.
Oh, okay.
Theta is in between 0 and 360. And so we got these. If we had kept our original one, that's a good point.
Yeah.
If we had kept our original one, 39.2, and we subtracted 71.6, then it would be outside the range. Maybe that's the way to go about this, to just like get your answers and just like check at the very end. Maybe that's more intuitive. Anyway, 69.2, 327.6, 69.2, 3.7.7. blame you. 71.6. It's just
Two
around.
decimal. I did it to one decimal place.
Okay. Yeah, they should have asked for it more accurately. Okay, any questions about that?
No.
I think you've got the idea. Change it into that form and then find it. Okay, this thing. Let me not that. This. Using it to find the maximum. This is what we used last time. There's probably some real easy way to do this. Yeah. We did most of this. Is it root 13? Screw it. Let's do it what you were doing. Okay. This one. No. We've done most of it already. Okay, here's one we did before. So we have 2 sine x plus 3 cos x. We wrote that as no, we didn't. All right, we'll just start fresh with this one then. Okay, how about this one?
So work out the formula for cos theta minus alpha, and I think that was cos theta cos alpha plus sine theta sine alpha.
Yeah.
And then make 12 equals to cos alpha, and 5 equals to sine alpha. And then do tan alpha equals to 5 over 12. And then do arctan of 5 over 12.
Yep.
And I got 22.6.
6 degrees. Okay.
Now do square root of 12 squared plus 5 squared.
Yep.
And I got 13.
Yep.
So will the final thing be 13 cos theta minus 22.6?
Cos theta minus 22.6. That's it. And part B.
Can I put into my calculator, and then it can into the graphing bit, and then it can tell the max and minimum value?
Go for it.
My max, I think, was minus 9.6.
That doesn't sound right. So imagine you have cos theta. What's its maximum?
Arc cos theta, or arc cos theta.
Y equals cos theta. What's the maximum?
360. Oh no, 1.
Okay. That becomes y equals 13 cos theta.
Um, 13.
Yep. So the y coordinate will be 13. What is the x coordinate of the maximum on cos theta? Y equals cos theta.
360.
Yeah, it's also at 0, which is much simpler.
So 0.
And so the x coordinate is usually 0, and then it becomes theta minus 26.2. So what type of transformation is that? What will happen there? Sorry, 22.6. Y equals the f of x becomes y equals the f of x minus 22.6.
Is that a translation?
Yep.
So does that mean the x coordinate will go up by 22.6?
Yep. And so the maximum for cos is usually 0, 1. 13 cos is 0, 13. And so if the x goes up by 22.6, what is the new maximum?
22.6, 13.
That's it. 22.6 degrees and 13. So just a series of transformations. 22.6. The maximum value is 13. There we go. And that occurs with these 13. Yep. So you convert it into that form, r cos theta minus alpha, and then you use that to find the new maximum or minimum. This is going to be the maximum y, stretch, y direction, scale factor r, and then the new x coordinate you can just do by solving this bit. Any questions there?
No.
Okay, so this occurs when cos theta. Oh yeah. That's a solving type of thing. Okay. This is a maximum type of question, but holy God, what else is here? Hang on. R sine theta minus alpha. I just want to see this one. Express 8 sine theta minus 15 cos. Alright, better do this.
Okay. So do I need to do sine? Sorry, I forgot what the formula for sine A minus B is.
Sine A minus B. That's given to you. Sine A cos B, and then just has a minus in between. Cos A sine B.
And so if we replace the thetas and the alphas there, and then that will give that cos. So that would be sine theta cos alpha minus cos alpha sine theta. And so would that then turn into cos alpha equals to 8 and sine alpha is equals to minus 15?
They both have minus, so it's just 15.
Okay, yep. So, and then I need to do arctan of 15 over 8 to get alpha.
Yep.
I got 0.0327.
2 decimal places.
So 0.033.
Okay.
So, hmm. Um, so I got, do I just need to add 23? Um,
What are you aiming towards? What form will your answer take?
the maximum value of g of theta.
You're not finished part A yet. They give you 8 sine theta minus 15 cos theta, and they want you to write that in the form r sine theta plus alpha.
Oh, so I need to do
minus alpha.
8 squared plus square root of 8 squared plus 15 squared.
Yeah.
And that's equals to 17.
Okay.
And so it'll become 17 sine theta minus 0.033.
That's it. That's part A. Now part B.
So I'm guessing I need to use my previous answer.
Yeah, I'm guessing as well with this one. So the G.
Do I need 23 to 17 sine theta and theta minus 0.033? Yeah, as the denominator, sorry.
Minus 0.033. Okay. It's quite tricky, but okay. So what would be the maximum of our answer for the first one?
When you say the first one, do you mean the first answer from 6A? Or
Yeah, from part A, what's the maximum?
is it going to be like is 0.033?
What is the maximum Y? Maximum output.
Could I just keep on subbing in answers to theta to find out what the max would be?
It's one way to do it. Maximum of sine theta?
0.
Goes apart in that.
1.
Yep. Maximum of 17 sine theta?
17.
Yes. Maximum is 17. Changing, like transforming in the theta direction will just change where the maximum happens along, but it won't change how high up it goes. So the maximum value of this is 17. So what can we do with that?
So if we know the maximum, would the maximum value of g of theta, would that just be like 10 over 17?
10 over 23 plus 17.
So 40.
Okay. 10 over 40.
Which is a quarter.
I'm going to write that as 0.25. This reminds me of bounds at GCSE. I think we might be able to get a different value. Let's just get the full range for this. 10 over 23 plus something. So what is the minimum of 17 sine theta?
Minus 17.
So what would this be if you did minus 17? 10 over 23 minus 17.
That would become 10 over 6.
10 over 6, which is 5/3, which is 1 2/3.
Yeah.
Which is bigger, 0.25 or 1 2/3?
1 2/3.
So 1 2/3 might be the maximum. I'm thinking because like bounds at GCSE, the bigger the denominator, the smaller the fraction. The smaller the denominator, the bigger the fraction.
Yes. Yeah.
Let me just try one more thing. You initially said 0. Sine theta can be 0. 17 sine theta also can be 0. What is 10 over 23 plus 0?
Okay. 10 over 23 plus 0.
Yep.
Is it just 10 over 23?
Yep. What is that as a decimal?
0.43.
Okay, so that's in between our two. So I think, yeah, so what is our maximum then?
So is the maximum 0.43?
No, we had a bigger output than that.
Plus a quarter.
We had a much bigger. The number shouldn't be getting smaller.
So we did 10 over 23 plus 17.
Yeah, and we got 0.25. We also got 0.43. Did we do something else and get a bigger number?
We took away 17.
Yep.
So do I? So it. So is the final max going to be 0.43?
That's not what you get when you take away 17.
So do I need to take the 0.25 minus 17?
No. 10 over 23, take away 17.
10 over 6.
Yep. Or 1 2/3. That's the maximum that this thing goes to. Find the value of theta where that occurs. So what value of theta gives you that maximum?
Put it into my calculator.
Go on then.
Okay.
That's what I'm doing. Although we do have enough to do it without it. Sin x. Oh, why did that happen? Okay. You can't answer that.
No, I got no solution.
It's just the zoom makes it a bit weird, but I think I'm not perfect with this calculator. I think this might change it a bit. Did that? I don't think it did. Graphical solve, maximum. I did change the view window to trig. When do you usually get the maximum for sine?
Every 80 degrees.
Yeah, or in every 360 degrees, because it repeats every 360.
Yeah.
Where do you get the first one?
90.
Yeah. What is that in radians?
Pi.
That's pi over 2.
Pi over 2, yeah.
Okay, so that's for y equals sine theta. We have y equals sine theta minus 0.033. What will that change?
The x coordinate has to go up by 0.033.
Yeah.
So it just goes 0.033 to the right.
Yep. 2 decimal places.
So, am I doing here pi over 2 plus 0.033?
Yep.
I got 1.6 0.
That's it. So that is 1.60. Okay. C1, find the minimum value of the g of theta.
Okay. am I just? Is this where would I just need to do like pi? So does it hit the minimum value at pi?
Does sine theta? Well, so g of theta is equal to y. So we're finding the minimum y coordinate first.
Yeah. Is it -1?
For sine theta, it's -1. For this crazy thing,
0.25.
yes, very good. And part 2.
Find the value of. So, do I need to go back to the 17 sine theta minus 0.033, and then try and solve for theta?
Well, what is it equal to?
That's what.
Where is usually the minimum in sine theta?
So do I need to make it equal to 0.25?
That is the y. We want the theta, which is like the x. For the maximum, for sine theta, it's pi over 2. For the minimum,
Pi.
Get smaller than that. At pi, it's 0.
Pi over 2.
3 pi over 2, 270. So 90, 180, 270, or a half, a whole 1.5 pi. So usually the minimum is at 3 pi over 2 for this one.
For this one, it will be sine 3 pi over 2 minus 0.033.
True. How did you get the maximum? The theta at which the maximum occurs?
So the maximum is 1.6.
That's where the maximum occurs. And how did you get that?
Pi over 2 plus 0.033.
Yeah. And so how do you get where the minimum occurs?
3 pi over 2 plus 0.033.
Correct.
Okay.
Because the whole thing's been moved 0.033 to the right.
I got the maximum as 4, or even to a minimum as 4.75. 4.75.
Seems all right. Minus 1.08. Was that what we said at the very beginning? alpha is 0.033. Let me check. Arctan 15/8. I'm in degrees. Change that into radians. How did you get 0.033? Arctan 15/8.
I'm not sure.
Okay, I don't know. Maybe it was just a typo or something in your calculator. But we should use 1.08 instead of 0.033. 1.08. So that is. So try 3 pi over 2 plus 1.08.
Okay.
So answer plus.
I got 5.79.
Yeah, so 5.79. And so if we just use 1.08 instead of 0.33, we've got the same thing. 5/3 is correct. That's 1 2/3. And 1/4 is correct. That's 0.25. Yeah, it's just a typo, I think, with the other one. Okay. Holy God. Very big picture. So part A is all right. Converting it into, instead of a mixture of sine and cos, into just sine. That part's all right, using double angle formulae. Second part is basically GCSE bounds. 10/23 plus all that craziness is the, I'll just do a big X. The bigger the denominator, the smaller the fraction. The smaller the denominator, the bigger the fraction. And so it's just, so it's kind of the reverse. So you put the minimum of this to get the maximum overall, and the maximum of y to get the minimum overall. And then you just compare with your sine graph to see where how to solve it. So for sine, the maximum occurs at 90 and the minimum occurs at 270. And so you just see we had to add on 1.08 or put it into radians. Have to add on 1.08 to both because it was moved 1.08 to the right. Any questions there?
No.
Yep. Let's see. So that's solving. That's all right. That is solving. It looks okay. I'll have to take a look at that, but it looks the same. 3 theta, that's the same thing. That is to find the minimum and solve in one question. That looks the same. Find the minimum and maximum and solve it. So you just put it in the form of r sine theta plus alpha. I'll have a look at those, but I think they're exactly the same, even though they have 2 theta. The cosec in the form 2 sine, that's the same thing. 2 sine theta plus cos theta equals 1. You put that into the form of r sine theta plus alpha to solve it. Let's see, solving type again. Yep. And then this one is very similar to the one we just did. 18/50 plus. You would use the minimum overall to get the maximum. Yep. That is the same. Okay, so you could practice that more if you want, but we've done every part of it. So what would you give yourself for that?
I'd say a half, I think. Some things are like okay, some things are like pretty hard.
So Okay, proving trig identities. All right, so I'll take a look at those, and if they're all the same, then we'll just move on to next thing next time. If there's anything different, we'll go over it, but I think they're all the same. Yeah, how is that for you, Andrey?
Tricky stuff, I think.
Yeah, we're getting there though. So modeling with trig functions, that's just applying it to the real world. And the one before that is trig identities. Is it? Proving trig identities. All right. We're getting nearly there, nearly finished this trig stuff. Any questions for me in general?
No, I think that's it from me.
All right, well done, Andrey. You did great. I look forward to talking to you after the weekend.
Yeah, see you on Monday.
All right, have a good one. Goodbye.